So you're a Java developer who's already mastered the art of the backend, but every time you go to make the smallest UI change, you need to mess around with this clunky, convoluted JavaScript front end. But today, I'm going to show you how to build the same quality web apps without ever leaving Java. And yes, I mean the UI as well. My name is Drew Harvey. I'm an engineer here at Vaadin, and today we're going to be walking through building a Java web app using the Vaadin Flow framework. This video is intended for those just getting started with Vaadin. I'm going to assume you already have some basic understanding of Java programming and that your Java dev environment is already set up. If you need help setting up an environment, we did post a previous video that walks you through it here. We will be using Spring Boot and Vaadin to build the application, but our focus will be on the UI. Before we start coding, let's take a look at what the Vaadin Flow framework actually is. Vaadin Flow is an open source Java web app framework designed for building web apps in pure Java, meaning you don't need to touch the HTML or the JavaScript. At its core is a large component library that consists of simple controls such as buttons and text fields, all the way up to advanced components such as grids, charts, and spreadsheets. Each of these components is a Java class, so if you need a button, you just instantiate a new button. And you add those components to layouts to arrange and organize your UI. Now that we've covered the very basics, let's jump right into the code. If you want to code along with me, I'll leave a link to the project down in the description below. Just download it and open it in your IDE. Now let's get to coding. Today, we'll be building an enterprise-style customer management app. The goal is to have something true to enterprise, but also simple enough that we can learn the building blocks of using Vaadin Flow. Now that we have our project open in the IDE, let's take a look at the source and kind of how it's structured. You'll see two main packages here, backend and UI. Backend is a pre-set up backend that will connect to the UI later, so we can kind of ignore that for now. And the UI package is where we will be doing most of our work. This is by no means a real architecture, it's just a simple split for the demo. Let's go ahead and open the HomeView class. Before we start modifying anything, let's run the application. I'm using the debug using hotswap agent run command. This lets me modify code and view it live without restarting the server. To do this, you need to install the Vaadin plugin in your IDE. I covered it in a previous video and I'll link that in the description. Okay, back to the home view. This is a basic empty Vaadin view, and the way that we know this is by this route annotation at the top. The route annotation tells the framework to serve this view or this class at a specific URL. Since we have an empty string passed into the route annotation, we're just serving this at the root, so in our case, that would be localhost 8080. We can also see that HomeView extends vertical layout. This is one of the most common layouts you'll end up using, and it simply stacks things vertically, so on top of each other. Let's start by creating a new text field for the user to input their name. All components and layouts in Vaadin are Java classes, so we instantiate them like we would any normal Java object. Then we add the component to our view using the add method, which comes from vertical layout, and we can immediately see it pop up in the browser so we know it is added to the view. Next, let's add a date picker component for taking the date of birth of the user. And again, we just create a new date picker object and pass in our label as a parameter, and finally use the add method to add it to our view. Again, we see it pop up right here in the browser and we can interact with it immediately. To make this look a little more realistic, let's add a save button below both of these fields. Again, we instantiate a new button here and we pass in save as our label. Then we'll add it to our layout using the add method. Now we see our save button pop up in the UI, and when we click it, it does nothing. So what we can do here is add a click listener to the button object. So whenever the button is clicked by the user, this code will be executed. And we'll keep it simple for now. We'll just show a notification on the screen. So now if we come over to our UI and click the save button, we can see these notifications popping up. So now let's add a second button. This time we'll add a discard button with the idea being in a form, you can clear the form or revert the changes that you've made. So let's create a new button and pass in discard as the label. And let's add another click listener here that will again use the notification system to tell us that we clicked the discard button. So now if we hop back to the UI, we can click the save button and see the notification, and the same with the discard button. But this looks a little odd having the buttons stacked. I think it would look much better if they were horizontally aligned, so side by side. And to do this, we'll create a new horizontal layout, which acts like our vertical layout, except for things are placed side by side. And we will add the save and discard button objects to this layout. And finally, we add this new buttons layout to our view. So once we save, we'll let the code reload, and there we go. We can see in the browser these buttons are now side by side, which looks a lot better. And this idea that you can nest layouts within layouts is quite core to the way you build UIs in Vaadin. Now that we understand the basics of creating new components and adding them to layouts, let's jump over to something a little bit more realistic. Let's jump over to our project files and create a new class. And let's call this class Customer List View. And let's have it extend vertical layout so that things are stacked vertically by default. And we need to add the route annotation so that we tell the framework this is a view we want accessible, and we will map it to customers. So this means going to localhost 8080/customers should bring up our view. In our constructor, let's add a simple button. That way we can verify that the routing is working and we know we are actually looking at the customer list view in the browser. So once we hit save, the code should be reloaded. And now if we go to /customers in our browser, boom, there is our new customer list view. If you get a routing error when going to /customers, try restarting the server. This is one of those cases where it might be needed. Now that we've verified the view works, let's start updating the UI to actually display customers. So first, let's add a new grid component. This is kind of like an advanced table component in Vaadin. And we'll pass in customer as the data type here. It's a class that has things like first name, last name, email. And we'll also pass in customer.class as a parameter. What this tells the grid is to generate columns based on the customer properties. So we should have a column for every property in the customer class. So we can already see in the browser that the columns were generated for the grid, but there's no data in them. So let's create a simple method that returns a hard-coded dummy list of customer objects. So I'm just going to call this getSampleCustomers. And then let's just return a new array list and populate it with some hard-coded customer objects. Go ahead and use whatever values you want here. It's not a big deal. So now we have our list of customers and we just need to add them to the grid. To do this, we call grid.setItems and we pass in our collection of dummy customers. And nice, we see our customers, but the auto-generated columns don't quite look how I want. For example, I don't want to see the ID column there, and I want to organize them a little differently. So let's actually go in and set up the columns manually. To do this, the first thing we need to do is go up to where we instantiated the new grid object and remove customer.class from the parameters. This essentially just tells the grid don't auto-create any columns. To manually add a column, we need to use grid.addColumn and then pass in a method reference to the property of customer we want to display. So in this case, we'll use getFirstName, and then we'll set the column header as first name. And once the code reloads, boom, there we can see now our grid has one column, and it is just the first name of our customers. So we can repeat this process for each property we want to display as a grid column. So now that we have all of our properties as columns, let's save. And there we go. That looks a lot better than before. While we're here, let's move grid into a private class variable. We're going to need to reference the grid object from other methods pretty soon. So I actually want the grid to take up the entire screen. So let's call grid.setSizeFull, which will set its width and height to 100%. And it doesn't seem to be working, and that is because the grid's parent layout, which is the view, also needs to be set to full size. So if we set that here and hit save, now we can see the grid is taking up the full size of the view, both width and height. And I think now would be a good time to add sorting to each of the columns. So this is really easy. In any column, we just need to use the set sortable method and pass in true. And I'll fix this weird indentation here, and I'll go through the rest of them and set them to sortable. Okay, now we'll save, and now we can see the sort icons in the column headers, and it does look like they are working. Now that we can sort the columns, it would be great if we could search through them. So let's add a text field that will be used for filtering all of the items in the grid. Before we do that, let's move our customers into their own private variable. This will be needed later once we're able to add and remove customers through the UI. So let's just populate it with our get sample customers. So now that list of customers only gets generated once when the view is loaded. Okay, so back to our search field, let's instantiate a new text field, which will act as our filter or search field. I'll leave the label blank for now, and let's add that to our layout. So now we need to know when the user enters text into this field. In Vaadin, there are several different ways to do this, but the recommended approach is to use signals. Signals is the reactive state management system in Vaadin. For those unfamiliar with reactive state management, what this means is instead of listening for data changes and manually updating the UI, we just define the relationship between the data and the UI, and the framework keeps everything in sync automatically. And again, if you're new to reactive state management, try to stick in there. If it doesn't click right away, that's totally fine. You'll get it after a few repetitions. For this case, we'll use a value signal object. It's just a signal that contains a single value, and it's of type string because it's a search value that's coming from a text field, and we'll pass in an empty string as the initial value. Next, we'll bind the signal to our text field. This essentially keeps in sync our signal value and our text field value. If the signal value is updated, then the text field will update to display that new value. And if the user changes the input, then that value will be written back to the signal. This might come off a little confusing at first, especially in a simple example like this, but you'll see some more benefits of using signals later. Just try to stick with it for now. Next, we'll add our function that actually does the filtering of the customers based on that user input in our search field. So let's create a new method here and call it update customer list. This is where the core filtering logic will happen. And we want this method to be called whenever the search value changes. So what we'll do is use a signal effect, which basically says whenever our search value signal changes, run this block of code. So in our case, run the update customer list function. And we'll add a parameter here for the search query string. And inside of the effect body, we need to call searchValue.get. Not only does this get the value of the signal itself, but it also tells Vaadin to rerun this effect whenever the search value signal changes. So if we hop back down to our update customer list function, we can start adding the logic for actually doing the filtering on our customer list. So we'll start with the full list of customers, and then we want to check to make sure the query string is not empty. Otherwise, we don't want to do any filtering. And then we'll just use a Java Streams filter method to compare that search query against the different customer object properties. And first, we'll check the customer's first name to see if it contains the query. And then we'll collect those items into a mutable list so that we can modify the list later when we start adding and removing customers. So nothing Vaadin specific here, we're just filtering this list of customer objects. And finally, we use this filtered list of customer objects and pass it to the grid via the setItems method. And actually, we want to set the query to lowercase. That way, our searches are not case sensitive. I've already applied to lowercase on the first name, but I need to apply it to the query string parameter as well. Okay, we saved and our code is reloaded. So let's try it out. If I type Alice and I hit enter, there we go. So we can see the filter is already being applied. If I type something here and hit enter, it essentially updates the search value signal, which triggers our signal effect and subsequently calls update customer list using the signal value, which is mapped to the text field. So let's jump back to our filter logic and let's compare it to the rest of the customer properties that we want to. I'll do it the same way I did first name by setting it to the lowercase and then checking if it contains our search query. There we go. And I'm going to skip customer since column. That property is a date. You could convert the date to a string and compare that the same way we're doing here, but I'm just going to skip it for now. So now if we jump back to the browser, I can start attempting to filter on these different columns. Let's try status. There we go. That worked. And let's try the last name. So there we go. That's working as well. And we'll try an email domain. Great. So it looks like all of our filtering is working just as we hoped. So if we jump back up to our search text field instantiation, and instead of using a label, let's actually set placeholder text that says search so the user knows what this field is for. So if we jump back to the browser, now the search field actually says search. That's a little bit easier to understand, and it is replaced when we type. Another thing I'm not loving is that I need to hit enter whenever I want the search to occur. So let's change this by updating the value change mode of the text field. And let's change it to lazy. What this will do is automatically apply the value after the user stopped typing for a short duration. So without hitting enter, you can see that the filtering is now happening as soon as I stop typing. This definitely feels more normal and what I would expect from a modern application. Before we continue adding features to the UI and adding more code here, let's organize this a bit by moving the search creation and the grid creation into their own methods. This will be a common approach you use because once you have 50 different UI components in a view, you're going to want to have some kind of organization, otherwise it'll get messy quickly. And for the grid method, we'll use the term configure grid instead of create grid since we aren't actually instantiating it here, we are just setting it up. And we'll leave the actual placement and building of the UI in the constructor. So now we're able to sort customers and search through the customers, but we still can't really interact with them. It would be cool if I could click a customer and view their details in some kind of modifiable form. So let's start by creating a form that maps to the customer properties. And just like for search and grid, we'll create a new method here that will encapsulate all of our form creation logic. So for this, we'll be using the form layout, which is obviously designed for forms. It gives us responsiveness out of the box, and it lets us configure things like where the label should be placed, whether it's above or to the left of the fields. And we'll just want to create components for each of the properties we want to display in this form. And for us here, we're basically going to mirror what we have in the grid columns. So I'll create a new text field for both the first name and the last name. Then for the email, I will use the email field component. This essentially checks that the email is formatted correctly before allowing the value. For the status, we'll use a combo box, which is essentially a filterable select or dropdown. And status on our customer bean is an enum, so we can just pass in the enum value set as the list of selectable items here. And finally, for customer since, I'm going to be using the date picker component, which you'll see in a sec. And you saw it earlier, but it opens up a calendar type of view where you can select a specific date. And then I'll add all of those fields to our form layout. And then we want to actually add the form that we just created to the view. And I think it would look best if we had the grid and the details form side by side. So let's actually create a horizontal layout and we will populate that layout with the grid and the details form we just created. And then we no longer need to add the grid directly, and instead we want to add this new horizontal layout. And awesome, we have our details form on the right and our grid on the left. It looks a little weird. I think the form's a little bit too wide and the grid is not wide enough. So let's go down to the form and let's actually update the form's width. Let's just set it to 300 pixels for now. We don't really need this form to grow or shrink anyway, so yeah, that looks way better, especially for this narrow screen size. So our form looks amazing, but it doesn't do anything yet. What we really want is to select a customer in the grid and have that form be populated. Similar to how we bound a value to the search field, we want to bind a value signal to the grid's selected customer. So let's create a new edited customers value signal of type customer, and we'll pass in null for the initial value since if nobody is selected, if no customer is selected, then the signal will hold a null. Once a customer is selected, then this signal should be updated with that customer object. So now if we hop down to the grid, what we can do is bind this signal to the grid selection. And we just want this to be a single select for now. So we'll call this as single select, and then we will bind the value of that single select to our edited customer signal. Again, this is a two-way binding. So if we programmatically change the signal value, then we'll actually see the selection change. And if we go on the grid and click a different row, then that will update the signal value. And just like with the search field, we want to listen to these changes in selection by using the signal effect mechanism. So let's add a new signal effect here, and we'll just have it pop up a notification so that we know it's working. And remember, we need to call the signal.get method in order for Vaadin to know that we want to rerun the signal effect each time the edited customer signal changes. So now if we hop back to the browser and we click a row, we can see the notifications popping up. So we know that we have indeed bound our new edited customer signal to the grid selection, and that effect is indeed firing. Let's go ahead and delete that effect now that we know the selection is working and the signal is working. And what we want to do here is we actually want to bind the form's visibility to whether or not a customer is selected. So if a customer is selected, we want to show the form. If no customer is selected, we want to hide it. We can use the form layout's bind visible, and then we can derive a computed signal from the edited customer signal by using this map method. And the cool thing here is that even though we're not binding directly to the base edited customer signal, the form's visibility still reacts to any modifications to the edited customer's value. We can see this working already in the browser. If we select a row, the grid is visible, and if we deselect it, it is hidden again. But it seems like there's something messed up. The full width and height of the page isn't being used, and I think it's something I messed up earlier. That horizontal layout that's holding the grid in the form needs to be set to full size so that it takes up the full width and height. There we go. So now we can see it is taking up the height and width of the view, and it's responding correctly when that visibility is toggled. I just realized that we actually don't need this grid.setItems call because we created a signal effect earlier when we implemented the search functionality, and signal effects automatically run as soon as the page loads or the owning component is attached to the view. So this is automatically running when the view loads, and it's populating the grid in our update customer list method. Now we want to update the details form so that it actually displays values from the selected customer. And to do this, we will use the Vaadin binder. The binder is used to connect bean properties to specific UI components. So we can instantiate a new binder and pass in the type customer. We then call the bind method on the binder, and we'll pass in our text field, and then we'll specify method references used for reading and writing to and from a customer bean. So what we're really doing here is creating a two-way binding between the text field and any customer object. The value displayed in the text field will be derived from customer.getFirstName, and if you modify the input of that text field, that value is written to that customer bean using customer.setFirstName. So now we have a simple binding setup, but we need to tell the binder which customer bean to actually look at. So to do this, we'll add another signal effect, and we want to call binder.setBean and pass in the edited customer's signal value. And because we're using edited customer.get, this signal effect will be fired every time the edited customer's value changes. And since we have it mapped to the grid selection, we can see that this effect is being fired each time we change the grid selection. And we can tell the binder.setBean is working because the first name field in our details form is updating based on the selection. Now that we've verified that selection and binding with the binder is working, we can go through the rest of the form fields and bind them to their corresponding properties in the customer class. So again, we're using binder.bind, we're passing in the component, which is the text field here, and then specifying the customer methods for getting and setting the last name. We can do the same thing with email, status, and customer since. So let's do that really quick. So now if we save and we jump back to our browser, we can click around and see that the details form actually does update according to whatever customer we've selected. This is awesome, but we want to validate the input before we write it to the bean. Let's start by making first name a required field. We'll need to change the methods we use to be more explicit. So instead of using bind, we'll use forField and pass in the component, and then we'll use the bind method to just pass in the get and set methods. Then we'll add this as required call. This tells the binder that if this field is empty, to mark it as invalid. If we jump back to the browser and clear the first name field, we'll see this red outline show up. This means the field's value is invalid, and invalid values actually stop the binder from writing to the bean. We can also hop back and specify an error message by passing in a string to the as required method. So if again we go back here and empty this field out, we'll see this new error message pop up below. Let's also update some of the other fields to also be required. We'll go through the exact same process for each of them. So now if we save and wait for the code to reload, we see the asterisks pop up in each required field. But what if we need more complex validation? For this, we can use the binder.withValidator method and provide either a pre-made validator or create our own validator. So for this demo, let's create our own just to kind of show off the functionality. So as part of our custom validator method, we have this value parameter. This is the value coming into the field that we're going to validate against. So let's just check if the value coming in contains an A character. And if it does contain an A character, we can return validation result OK to signal that it did pass validation. Otherwise, we know that it failed validation, so we need to return this validation result.error and provide an error message to display. So now if we hop back to the browser, let's change the last name to not contain an A, and we see that error message pop up right away. If we add an A and click away, there we go. The error message is gone. It's a valid value and an invalid value and back to valid again. Before you go and implement a custom validator, make sure to check if Vaadin offers one out of the box. There are many baseline things covered, such as email formats, number ranges, string lengths, and many more. So as an example, we'll add an email validator, which is part of the base Vaadin framework. And if we go back to last name, the only values that will be accepted is if they are formatted like a proper email address. Let's go ahead and delete this validator since it was just for the demo. Let's go ahead and add back those error messages. That way, when the user inputs something invalid, it's a little bit more specific on what they need to fix. And it seems like those error messages are coming up just like we wanted. So our bindings are working great, but right now the values are automatically written to the bean as soon as the field value changes, which might not be what we want. Instead, let's add a save button and a discard button so that the user can explicitly tell us when they want to save the changes, or if they made a mistake, they can hit the discard button and revert it to the previous state. So let's start by just creating those two button objects. And let's use a horizontal layout so that they are side by side at the bottom of our form. And then let's add it to our form layout. And we should see it pop up here on the right. There we go. Cool, that looks great. Right now, we are using the binder in what's called write-through mode. So each time we modify a field, that value is immediately written to the customer bean that we provided to the binder. And the reason this mode is active is because we called the binder's setBean method and passed in our customer bean. In most cases, we'll actually want to use the buffered mode, which means changes to the fields will not be written to the bean until we explicitly tell the binder to do so. And the first thing we need to do is update that set bean call to use read bean. So instead of passing in a bean that will be written to, we're telling the binder to only read the values from the bean we pass in. And if we jump back to the browser, we can see the binding is still working, so we know that the customer values are still being read in correctly. This binder read bean method makes the discard implementation very simple. All we need to do is add a click listener to the discard button. And because we haven't written any values to the selected customer or the edited customer signal, we can just pass in the edited customer signal's value once again to revert those fields to what they were before. And the reason we're using the signal.peak method here instead of .get is that we only need the signal's current value when the button is clicked. We don't want to run this code automatically whenever the signal changes. The button click already decides when it runs. So let's jump back over to the browser. Let's try changing Carol's first name to something. And if we hit discard, it should reread that bean. There we go. So you can see that the values snap back to the original values in that Carol customer bean. Now that we have discard done, let's start working on the save implementation. So again, let's just add a click listener to the save button. And what we can use here is the binder's write bean method. What this does is it takes a bean and it writes the values of the form to that bean you pass in. If the state of the form is invalid, so if a field is marked as invalid, then this write bean method will throw an exception. So I did actually make a mistake right here. I shouldn't be throwing a new runtime exception inside of that catch statement. Typically, you could do nothing because we show the errors in the form itself, or you could log it or show a message in that catch, but you definitely don't want to be throwing a runtime exception there. So just remove that line if you're following along. So now that the values of the form have been written successfully to our customer bean, let's call this update customer list to refresh the grid. And we see here we don't have an empty parameter version, so let's make an overload now. And we will just fetch the search value and pass that into the base method here. And the reason we do this is because we want the active filtering to still apply even when we're modifying customers. And now back in our browser, if we modify Bob's first name and we hit save, we can see it immediately updated in the grid. And Bob's a great name, but I think I want something a little more zesty like Johnny. There we go. Maybe some exclamation points. Yeah, that's much better. Let's hop back up to the save logic and let's actually move it into its own method, just to keep things a little bit more organized. So binder right now is a local variable, so let's actually move that up to a private class variable. And finally, let's call that save method that we just created in the save buttons click listener. I think the UI is looking pretty decent so far, but the search field is looking a little lonely up there. So let's actually change this to more of a toolbar and we'll add some more things to it. So first, let's change this return to a horizontal layout because now this component is going to return a layout that contains multiple components. And I think the first thing I want to add is a title for this view. So let's instantiate it as a new h3 component, which is the HTML header 3 element. Import that. I also think that a button for adding a new customer would fit really nicely up here. So let's create a new button and let's just use a Vaadin icon, probably the plus symbol that would fit well here, just to keep it nice and simple. This should look a little bit more clean than actually spelling out add customer in the label. And let's finally add all of these components to our horizontal layout. And let's actually update the method name because we are no longer just creating search. It's more like a toolbar. And we'll do the same for the variable name. So now if we hit save, we should see these changes. There we go. This looks pretty good, but I want the search and the add buttons to be aligned to the right side. So what I'll do here is use flex grow 1 on the title component. What this does is tells the title to take up the full remaining width. So we'll actually push the search element and the add button element all the way to the right. So there we go. We can see it working here. That looks a lot better. So we have the add button, but we need to actually wire it up to something. So let's create a new method called add customer down here. And because we already set up binding for that details form, we can reuse it here. So let's just update the edited customer signal and set a new empty customer bean, which will be reflected in our customer form. So now let's wire up this add button using another click listener. And hop over to the browser and see if it's working. Nice. Okay. So we know that edited customer is getting set properly, and we have this empty bean being read in here. So because we're kind of mocking a backend right now by using this in-memory list of customers, we need to add a special clause here that says to add the customer bean to our customers list if it doesn't already contain it. And once again, we're going to use the signals peek method instead of get because we just want to get the customer object from the signal and we're not within a reactive context. Okay, maybe that's too many edited customer peek calls, so let's just grab it at the beginning. And paste it in here. There we go. That's a little bit easier. Let's try it out now that the code's reloaded. Let's refresh really quick. Okay. And put in my details. That is my real email address, of course. Click save. There we go. There's the new customer. Cool. So our add function is working. Now the logical next step is to add a delete button, and I'm going to add it to the bottom of the form. So when you click a customer, you'll be presented with that delete button option. And let's add a click listener that I will point to a new method that we have not created yet. And let's add it to the buttons layout so it shows up at the bottom as well. And so let's implement this confirm delete method. And what we want to do here is display a confirm dialog. because it's always good to check with the user before they delete your favorite customer. So we can use this confirm dialog component, and then let's set the text body to a basic, are you sure you want to do this? And we want to give the option of canceling out, so let's set cancelable to true. And finally, we will open the dialog by calling .open here. So now if we hop back, we should be able to bring up this dialog by clicking delete. Perfect. Awesome. Okay. So now we know the dialog is working. The delete button's where we want it to be. So now let's actually add a confirm listener, which gets fired when the user opens the dialog and clicks that confirm button. And we want to get the customer that is currently selected. So that will be in our edited customer signal. And again, we're using peak because we just want the value, nothing else signal related. And let's call that list remove method and pass in that customer object. And finally, refresh the customer list since it's changed. And we should be good to go. So let's save this and hop back to the browser. Give it a quick refresh and let's try deleting Alice. Perfect. There we go. Alice is gone, but not Bob. We want to keep Bob. He's good. So let's make this look a little bit better. I want to actually display the customer name in the confirm dialog. So let's just grab the customer object and format this string so that we can pass the first and last name. And instead of using another peek call, let's just get the customer object at the top, and then we'll use it in both places. I also want to add a header to the dialog so that it is more than just a body of text. And finally, let's change that confirm text on the button to actually say delete so it's a little bit more explicit. And if we save, code's reloaded, hop back to the browser, click the delete, and there we go. We can see our changes live right here. Awesome. So one other thing, we don't want the delete button to be enabled unless it's an existing customer that's selected, not a new customer. So we can use this bind enabled method on the button itself, and we can pass in our edited customer signal, and again, map a computed signal to check if we want that button to be enabled. So I did this a little prematurely. We don't really have any way to test if it's a new or an existing customer, but we'll come back to this and update it once we have the backend wired in. Then we'll be able to actually determine if it's a new customer or an existing customer. But the point I was trying to make here is that you can actually bind a lot of different component states and component properties to signals, not just the component values. So things like visibility and enabled state can be bound to a signal. All right, so the time has finally come to wire up to our real database. And let's hop into that backend package that we've been hiding this whole time. And if we look at customer service, you can see it's very simple CRUD operations, find all, save, and delete. We're still using those same customer objects. And we have this data SQL here, which populates our embedded H2 database on startup. So we'll have a lot of customers to work with here. And even though we didn't walk through all of the different backend classes, it's a basic Spring backend. So if you're not familiar, feel free to look at them. They're pretty basic. Let's get started by removing our customers list. We no longer need this kind of fake hard-coded list. And we are going to inject in the customer service, which is from our backend, which we had just looked at. And we'll just use a normal constructor injection here. And now if we scroll down, we'll see a bunch of errors because we deleted that customers list object. So let's go down to update customer list, and we'll update this by calling customer service.findAll, which will fetch customers from the backend. and we can just reuse this filter here. It doesn't need to be a separate variable. So that fixes our main fetch. Now let's hop up to save, and we no longer need this special clause for adding a new customer. We can just use the save method and pass in the customer bean, and the service will determine whether it needs to update an existing customer or add a new one. And same with delete here. We just use a delete, pass in the customer, and that's it. So now we'll want to restart our server or start it back up in my case. And there we go. We can see that huge list of new customers coming from our actual embedded database. And we can make some modifications to Alice and save it. And we see that it does indeed update just like it did before. And yeah, that's all we needed to do to switch over to using a real backend. And like I mentioned earlier, let's hop back to the delete button and finish that bind enabled logic. So we only want to show the delete button if the customer is coming from the database. And if it's coming from the database, it always will have an ID. So we can just check here if it's not null and if the customer get ID is not null. If it is null, it means that we're creating a new customer via the add button we added earlier. And if we click a row, the delete is there. If I click add, the delete is disabled because there's no ID from that new customer bean that we created when you click the add button. And to make this code a little more clear, let's just extract this logic into a isNew method that will check whether or not a customer object is new or if it's an existing object from the database. So one thing would be cool is if the save button's text actually updated depending on whether you're editing a customer or creating a new one. So let's hop up to the save button here, delete the label, and we're going to use the save button's bind text method. And again, we're going to use that edited customer signal and create a computed signal from it by using the map function. And we can just use our isNew method that we just created to pass in the customer object and determine what the label of that button should be based on whether the customer is new or existing. So if we save that and hop back to our UI here, now we can already see when we click these existing customers, the button says save. And if I click a new customer, we have create. That's cool. So that's a little bit more explicit. So one issue we have is that we can't navigate to the views without modifying the URL directly. So we really need to add some kind of UI shell so that we can have a main navigation and maybe the app title as well. So to do this, we're going to go into the UI package and create a new class, and we'll call it main layout. And we want to extend app layout here, which is the base class for that UI shell. And then we want to annotate this with @layout. What @layout does is it tells Vaadin to apply this to every view unless the view specifies otherwise. So right there, if you caught it, as soon as we saved, we now have this frame around our entire UI. So let's create the constructor, and we will do most of the construction right here. We are going to set our primary section as drawer, which means the navigation will be on the left side of the UI as opposed to across the top. And let's create our nav using the side nav component. And we'll create nav items for each of our views. So home view and customers view. So we have the label as home, and then we will pass in our actual home view class reference here. And I want to add a home icon at the end of it as well. And before we do customers, let's add this to the layout just to make sure it's working. So we'll add it to the drawer, hit save, and there we go. Awesome. So we can see our navigation here on the left. If we click it, it brings us back to the home view. And let's go ahead and add the customer view next. side nav item. We'll call it customers, provide that customer list view, and let's use the user icon here. Kind of looks like a customer. Hit save. There we go. Awesome. So you can see that whatever view is selected and active is automatically highlighted as active in that UI as well. Now let's hop back and add a logo and an app name. For the logo, let's just use the Vaadin logo. So we'll create a new icon. And for the name, our application is called Polaris CRM. So we'll just create a new span, which, yes, is like an HTML span. And we will provide the text there. Then we can create a horizontal layout so that they are side by side. Pass in the logo and the app name. And finally, we will add that to our drawer. Code's reloaded. There we go. We can see our app title, logo, and then the navigation that's working. And by default, horizontal layouts do not have padding set. So let's call our header, which is a horizontal layout, and set the padding to true. And there we go. That's a little bit better. That adds some space around the logo and the app name. Now I want to go back through the app and do some UI polishing and kind of make it our own. So let's actually go back to the save button in the customer list view. And let's add a new theme variant here, which will change the appearance of the button. So we'll do add theme variants, and then we'll pass in the button variant. And I want to use primary, which will fill in the background of the button. It makes it stand out a little bit more. So if I save and jump over and click a customer row, there's the save button. You can see now it's that solid blue color. It stands out. It looks a little bit nicer. And there are quite a few button variants. So let's actually go to the delete button and let's add some theme variants to this to make it stand out as well. So I think for this one, I want to use the air button variant, which will color it red. And then I also want to use the tertiary button variant, which will basically take away the button border. So if I hit save, there we go. We can see that the delete button now looks a lot different. And I like how this looks. It's a little bit more clear. I want to do the same thing with our add button, which is just an icon, but I also want to set that as the primary theme variant so that it stands out a little bit more. Yeah, that looks way better. Most components in Vaadin come with theme variants, so make sure you check what theme variants are available before you start implementing some kind of custom style. So one other thing I wanted to change was that delete confirmation dialog. When we open it, that delete button is blue, but I want it to be red so that it's obvious that they are removing something. So the confirm dialog actually does offer us a place to pass theme variants to this button. So we can call set confirm button theme. And here we need to use string values, but I will just pass in primary and air. And actually primary was not even needed because it defaults to primary, but we can see there, awesome. Delete is red just like we like it. It's very obvious. Theme variants are great, but sometimes we're going to need some custom styles. For example, here, maybe I want some padding above the form so that the search in the form is separated more. I can go to our form layout and call get style and set the padding top CSS value to 30 pixels. So get style returns a style object for that component, which exposes a lot of methods that map to different CSS properties. And we can see in the browser that the padding is added above the form, just like we wanted. If you're somebody that prefers using CSS classes and files, Vaadin also supports that. Let's say we want to apply a custom CSS class to our app name. We can jump down to Resources, Meta-INF Resources, and open this style CSS. Here we can define CSS classes, and then we can pass those class names to any component to have the CSS applied. So let's set the font weight to bold, and let's increase the font size a bit. So we have this app name CSS class, and if we go back to our component, we can call the add class names method and pass in that CSS class name. Now, if we save, we can see it change in the browser, so we know that CSS is indeed being applied. And I don't love how big the font is. Let's try lowering it a little bit. So let's do 1.1 instead. And the cool thing here is as soon as I save, I see the changes live. Eh, maybe we just keep to what it was at originally. Yeah, I think that looks better for now. Just keep the font weight bold. Vaadin comes with two app themes out of the box. Right now, we've been using the Aura theme, which is the latest theme from the framework, but there's also a Lumo theme. So if we jump over to our application class, we can see this at style sheet Aura style sheet. So this is essentially saying import the Aura theme's styles. And if we change this to use lumo.stylesheet, and you might need to restart your server here. Live reload doesn't always work for changing these style sheet imports. So let's restart. Once our server is up, we'll see on the right that the entire look of the app changes. And there we go. You can see it completely changed how it looks. It's a lot more square. And let's extend this out a little bit because the sidebar is wider now. But this is another base theme that you can use if you prefer this look. So let's actually switch back to Aura, which we were using before. And let's actually change this to a dark theme. We can use this at color scheme annotation to define whether we want a light, dark, or even system color scheme. And both Lumo and Aura themes out of the box support both. So I think we're going to have to restart the server again for this one. But once this loads, you should see the whole color scheme shift to dark. Nice, there we go. And we can see clicking around that not just the background updated, but the entire theme has been updated to fully support this dark mode. So I actually want to change the color scheme to be synchronized with my browser or operating system. So what I'm going to do is change this to light dark. So this will actually synchronize with my Chrome browser, whatever my Chrome color settings are set to, or to your operating system's color scheme. And because I have Chrome in the lighter color scheme mode, this should switch our UI to a light theme. Perfect. Both of these Vaadin themes are driven from CSS variables that can be overridden. So if you change these CSS variables, they actually cascade down through the entire theme. And an easy way to demo this is by using this tool we have on GitHub to kind of click around and preview themes or even generate random themes. And this is a proof of concept. This is kind of just a fun tool we have right now. Hopefully it's still around when this video comes out. But you can kind of just click around, randomize things, look for something you like, and then you can even walk through and customize every little aspect. So if you wanted to match your brand colors, you can easily do it here. And maybe my brand's color is fuchsia. So I'll click that here. And I found a theme I like. I like this sunset glass theme. So if I click that, then I can hop down to export theme CSS and copy all of the custom CSS here, and then just jump over to the project and paste it in our styles CSS file. And just like that, I've applied the custom theme. You can see the app looks totally different, and all it took was customizing some of those CSS variables, and it cascades throughout the entire design. And this is great because it makes it easy to keep your look and feel aligned with your branding while still utilizing those really high quality Vaadin themes. And here I'm just updating those CSS variables in our styles.css, and you can see them changing in real time. So you can kind of mess around with this and find the colors that you like this way as well. Now I want to take a quick look at the Vaadin add-on directory. Add-ons are third-party or community-built extensions for Vaadin that add components or functionality that isn't included in the standard framework. So we're here at the add-on directory homepage, and let's take a look at this full calendar for Flow add-on. And I want to check it out. Okay, it looks pretty cool. I think this would be great in my app. So first you'll need to log in. After that, click this install button. I'm using Maven, so I'll click this Maven POM. And I will copy the dependency and hop over to my POM XML. And I'll just add it to the bottom of my dependency list right now. Hit save, reload my Maven project, and then I'll start the server. So now that our app is up and running, let's hop over to the main view. I'm just going to remove everything from here for now. And I want to create a new calendar object. And we can see that this full calendar class is now available to use. So I'm going to set it to the full size and add it to my view. And now we'll save and wait for the code to reload. And there we go. There is our new calendar component. Looks amazing in our app. And if you ever come up with any additional functionality or components for Vaadin that you want to share with the community, you should absolutely upload it to the directory. And the final thing I want to touch on is Vaadin Copilot. You can see me hovering over this widget in the Vaadin UI. This is a tool that allows us to not only look at properties of things in the UI, but actually modify them from the browser. So here I've just changed the view title to best customer, and you can actually see it updates the code in the IDE. Yes, the indentation sometimes gets broken, but that's not a big deal. We'll fix that. If you aren't exactly sure what property needs to change, you can actually use this prompt feature to just describe the change that you want, and Copilot will take care of it. So here I want to change that search text to say filter instead. So I'll prompt it and hit enter, and I'll just wait for it to complete. And we can see back in our IDE that the code has changed for that set placeholder call on search. And this is really just scratching the surface for what Copilot can do. I really recommend you check it out. So that's going to wrap up this video. I know it was a long one, but I'm glad you made it to the end. I hope you feel a little bit more confident starting your UI journey using the Vaadin framework. If you have any questions, comments, or even best practices for other beginning developers, be sure to leave them down in the comments below. I'll be reading every single one. Again, my name's Drew here at Vaadin, and I'll see you guys in the next video.